So at the end of the last bit, we were talking about the competition for an exposition building in Hyde Park that was to take place in 1851. And we showed this drawing, and I said that this was Joseph Paxton's late entry to the competition. And even though it's a kind of sloppy drawing just done on a sheet of blotter paper, it's absolutely brilliant in encapsulating what Paxton proposed to do to build what became known as the Crystal Palace. On the top is a section, on the bottom is an elevation, and Paxton's genius was realizing that you could build a building infinitely large if you broke it down again into a single section that you could mass produce, just like the Chatsworth Great Stove, the one drawing that defined virtually all of the building that went into that particular structure. Well, here he has a section on the top, and you can see that there are cast iron columns, and we'll see that those were supplemented by cast iron trusses and also by some wrought iron purlins. And you can see that he's sketched ridge and furrow glazing across the top of the roofs. And then on the exterior of the elevation, what he's proposing is that basically you define a single elevation module, you build hundreds of those in cast iron and glass, and you simply mass produce the building in a handful of workshops throughout Great Britain. You ship them by rail to London, and you assemble them on site. And that is exactly what happened. Paxton was not only a clever engineer, he was also a clever marketer. And so he went to the press and said that he had come up with a solution to solve this debacle. And in fact, he was able to build the Crystal Palace in just 36 weeks. So met the deadline, and the exposition opened on time. The building was enormous. It was 1,800 feet long, so almost a third of a mile. And as you can see, the plan is just kind of dotted with cast iron columns. We might remember when we talked about the Roman Colosseum, we said that it wasn't a particularly impressive building in terms of its span, right? Structurally, it was just repeating a module dozens and dozens of times. The Crystal Palace is sort of the same way. The only major span in it was added at the last minute. The transept, or the short central axis, was done to save a couple of trees that were in the park. None of the other spans in the building are really that impressive. There were bridges, certainly, and even by this point, sheds that had larger individual spans. What was most impressive was the process, the fact that Paxton developed this single section, broke the section down into wrought and cast iron, into glass manufacture, and then into manufacturers of timber mullions, a single shape that we'll look at here in a second, that was able to take the glass and attach it to the iron frame. And by simplifying, again, the kind of algorithm, the instructions to the fabricators, he was able to have all of these various trades just mass produce a very small handful of different elements, but in great quantity. And then those were simply assembled on site with very little in the way of masonry. The only kind of wet construction went into the foundations, which could be relatively shallow since the building was so light. And here are really the two key elements. On the left, a typical structural and cladding module. There are two cast iron trusses on either side. There are beams that are cast iron on top, and you can see thinner wrought iron rods taking the tension in the beams running from girder to girder, or truss to truss. And then you can see a single glazing module repeated just infinitely across the roof of the Crystal Palace. Paxton did his research. He figured that the largest piece of glass that could be produced by factories in Great Britain was about 10 inches by 48 inches, so not quite a foot by 4 feet. And he based the module of the Crystal Palace, and thus the dimensions of the overall building, on that, on what manufacturers could easily produce. And on the right, you see his design for the mullion, the combination structural piece that's going to hold the glass in those little slots, and the rain gutter that's going to carry the rain off of the roof. These were made out of spruce. He went to the timber industry and said that he just needed an endless amount, something like 260 miles of 5-inch by 5-inch spruce timber. And then, as we'll see, he developed a lathe on site that could just day after day turn this shape out in section from the piles of spruce that were delivered to the job site. So these basically are the construction drawings for the Crystal Palace, along with a typical elevation module that you see here on the left. Two slightly different versions of the same shape, one of which had louvers at the top and bottom, so a way to bring in some fresh air, but otherwise just hundreds of these modules. And you can see that there's a cast iron arch that's basically serving as a moment connection between the columns on either side. And then on the right, this is a bracing bay where wrought iron rods are being used as cross bracing to steady the cast iron structure. We talked when we looked at iron about the fact that it's very difficult to get stiff connections in cast iron. This was a fairly loose building, and it relied on a series of shims between the cast iron trusses and columns to create reasonably tight joints. Not maybe something that you would want to do in a multi-story building, subject to really, really high wind pressures, or in a building that you wanted to last for any real length of time. The Crystal Palace only had to stand for the length of the exposition, or a little more than a year. And so crews could go around and tighten up these joints by pounding more shims into the connections between columns and girders as they went. The job site itself, maybe as clever as the building was the creation of all of these machines that could mass produce the elements that Paxton needed to actually build the structure. So on the top, you see the lathe that is just going to create miles and miles of mullions out of these raw spruce timbers. You can sort of see the cross-sectional shape of the mullion there coming out of the lathe. And then on the bottom, you can see machines that are helping to cut the glass. On the upper right, cranes that were specially designed to fit within the module that could just sort of walk down the job site, lifting these girders into place as they went. The left, here you see the process, and the iron frame is both lightweight and, as you can see, completely standardized. So all of those truss pieces were mass produced to a couple of different shapes. You can see the large arches on the ground. Those are going to form the transept over the center aisle, and you can see the trees that he was instructed he had to save at the last minute. And then on the right, you can see that the structure is proceeding ahead of the glazing. The glazing is happening in the background. And if you look closely, you can see another invention that Fox and Henderson, the actual builders of the structure, the contractors, developed as they were beginning to do the glazing. They actually realized that they were wasting a lot of time by having workers climb ladders and come back down each time they were putting a sheet of glass in. So they developed trolleys that could run along the gutters and that could be used as a kind of base for glazers to work as they sort of back their way along the structure. On the right, just to give you a sense of the scale, this is during the reconstruction of the building after it was removed from Hyde Park and moved down to Sydenham in southern London. But you get a sense for the system, but also the scale of the operation. Those 10 by 48 pieces of glass were not only easy for the manufacturers to make, but could also be handled by a relatively small crew. Right? It's not a tremendously large piece to put in. It's sort of broken down to human scale. So there is the transept. You can see the arched transept that Paxton had to come up with at the last minute. But other than that, you can see that the building is just a repetition of exactly the same module hundreds and hundreds of times. And this is, I think we can call this really the first mass-produced or industrialized structure, certainly of any scale, in the world, and a direct product of the Industrial Revolution, right? So we looked at buildings like Coalbrookdale. We looked at buildings like the British Mills. Here is something where they have literally gotten rid of masonry entirely, right? The entire structure is iron. The entire cladding is either timber or glass. And this is really probably the first building in the world of any reasonable scale to dispense entirely with traditional building practices, to be made completely by industrial means. It's typical elevation with the transept, and even though that transept was a sort of last-minute addition, it became the symbol, really, of the building. And you can see we have limited number of photographs from the interior, but this perspective gives you probably the best sense of what it was like inside. Now, of course, it ended up being filled with machines and products of various countries' industries, but you get a sense for the lightness and the spaciousness that you must have felt walking into it. Similar to the Palm House at Kew Gardens, but on a gargantuan scale. So imagine combining the lightness of Kew Gardens, the novelty of that, which by this point was only 3 years old, so still very fresh in people's minds. But imagine combining that with the scale of the largest possible Gothic cathedrals, right? This must have been absolutely mind-blowing to the public, and it aroused an incredible amount of interest and press, both in Great Britain and abroad. In a couple of weeks, we'll look at kind of reactions to industrialization, and one of the most interesting ones was John Ruskin, a philosopher and aesthetic theorist, who actually delayed publication of a book that he was getting ready to put out because he came and saw the Crystal Palace and had such a strong reaction to it that he actually pulled the book from the printers, wrote a new chapter about the Crystal Palace, and then had it go to publication. So this is the sort of impact that this had. This is something completely new, not only in scale, right? It was by far the most enormous building in the world by volume, but also by appearance. It wasn't thought of necessarily as architecture. It was thought of as construction or as engineering. Today we look at it and we find things that resonate with the way we think about architecture today. But that's because we're very used to the results of mass production, right? The extraordinary repetition, the kind of lack of hierarchy, the sameness or the rhythms that you get from these regular structural bays. All of that is new in 1851, and it is both thrilling to some and wildly kind of disconcerting to others. The legacy of the Crystal Palace is complex, and I'll talk about some of the spin-offs here in the closing bit of this lecture. But the palace itself, as I said, was rebuilt in Sydenham in South London, and it was turned into a pleasure palace, so sort of a public set of gardens and amusements, and enjoyed a sort of 80-year career before it burned to the ground in 1936. And this, of course, reflects another problem with iron construction, right? None of the Crystal Palace's ironwork was fireproof. There was no time to put all of the masonry around all that iron that you would have needed. The fact that it survived 80 years full of flammable contents is pretty impressive in and of itself. And it's true to say, too, that it wasn't a perfect building. Even during the year it was open in Hyde Park, it required constant maintenance to keep the joints between its cast and wrought iron elements tight. And the glass roof leaked, as you might expect one of the first, earliest, largest glass roofs in the world to do. There were something like 1,000 leaks documented during the year it was opened in Hyde Park. Some of that was due to the timber industry's inability to get that much wood to the job site on time. It was supposed to be seasoned and dried, and a lot of it was turned into mullions while it was still green, so still wet. And as it dried out, it twisted in ways that opened up holes in the roof. But all of that, I think, pales in comparison to the fact that this was actually done, that it was built from scratch in 36 weeks. and that it was built in a way that relied on these new industries, these new products of the Industrial Revolution, steam-powered industries that could produce hundreds or even thousands of elements within a very short period of time, and again, thanks to steam power, get them from throughout the industrial areas of Britain to London in time for them to be put onto the structure on the job site. So like many other great projects that we've seen so far in this course, the Crystal Palace was not only a noun, but it was a verb. That Paxton wasn't only designing the finished product, but maybe more importantly, he was designing the process. And in the concluding bit of this lecture, we'll look at how some of that evolved through the rest of the 19th century and well into the 20th.